I was instructed here in number 8 to find parametric equation of a line which is perpendicular to a plane described by this equation and passing through a certain point. So I wanted to start out by talking about that equation. Let me see, looking back at 8, the wording of the textbook is perpendicular to the plane 3x plus 7y minus 5z is equal to 21. I don't like to call equations planes, or I don't like to call equations geometric objects in general. I like to say that algebraic equations have solution sets, and those solution sets have visual interpretations. And so I wanted to start out my writing with the solution set 2, and then I wrote this algebraic equation. I say is a plane. And the relevant information here is that the normal vector to the plane is just the coefficients of x, y, and z in the components of a vector, 3, 7, negative 5. And so from that, we can say that the line through the point 2, 4, 5 that is perpendicular to this plane lies in the direction of that normal vector and has the point 2, 4, 5 on it. So we'll make 2, 4, 5 an initial point, and 3, 7, negative 5, the direction, we'll just add on some multiple of that. And I'm in the middle of working on a drawing, but I wanted to note that I don't actually use this name R of t again to refer to anything, so really I would say this is optional. We didn't have to write the symbols R of t. I could just write down this algebraic expression, and implicitly what I mean there is a function in the natural domain. The natural thing to assume about the domain of that function is that that variable right there can take on any real value. So this is a function from R to R3, conventionally. Alright, so I was in the middle of drawing this. First I wanted to draw the solution set. That's in green. Now I looked at this equation and I thought, okay, in order to draw a plane I need to know 3 points on the plane. And so I was thinking, what triple of numbers could I substitute in for x, y, and z to make this equation into a true statement? Certainly 3 times 7 is 21. So as long as I make these two terms disappear, 7, 0, 0 tells me to substitute in 7 for x, 0 for y, and 0 for z, and that would make this into a true statement. So 7, 0, 0 is one of the solutions to this equation. Similarly, 0, 3, 0 is another solution to this algebraic equation. And 0, 0, negative 21 over 5. So the 5 right there would cancel that 5 and leave me with a negative 21 times negative 1, or positive 21. Okay, so those 3 points are on the plane, and I can visually hint at the plane by just connecting those dots. And it's not the easiest thing to picture, but this plane goes away from us and back down there, so perhaps I should make this darker. This actually is coming towards us, and that is going away from us, so I'll make it taper off. This line over here similarly is going away from us, so perhaps I should make it darker over here and lighter back in there. And this line over here seems to be about the same everywhere, so I made a mistake earlier, so I was doubling over it. Okay. Now, we have a vector which is normal to that plane. It is the vector 3, 7, negative 5. I'll underline that in red just so visually you can see what I'm referring to. 3, 7, negative 5, that's 3 out in the x direction, 1, 2, 3, and then over to 7 here. And then negative 5, I need to go down 5. 1, 2, 3, 4, 5, that's just below this. So let me just get an idea of the distance. That's from the tip of my finger down to that wrinkle right there. Okay, tip of my finger down to that wrinkle right there. That put us right there. So a normal vector to that surface, well, this is the direction normal to that. Now, the base of this thing is not, right, on the plane. Where I drew the tail of this vector is at 0, 0, 0, and 0, 0, 0 is not at all on this plane. So I should maybe draw another copy of this vector is whose base is at this. So maybe I could put it right here because I know that that point is on the plane. There we go. So both of these guys are 3, 7, -5. And it should seem a little bit plausible if this part of the plane is closer than that part of the plane, that of course this guy has to be tilted downward in this perspective. Alright. So next I am meant to put in the point 2, 4, 5. 2, 4, 5. That's 2 out in this direction, 1, 2. And then over to 1, 2, 3, 4. Okay, that puts me about here. I'm going to go up to 5. 1, 2, 3, 4, 5. Now somewhere up here, I need to draw a point, and that will be obtained by drawing a line parallel to that one. That puts me about over here. And good thing I used blue, because I'm very close to that label 0, 3, 0. This will be the point 2, 4, 5. And if I attach my red vector to that, like so, and in blue I start at 2, 4, 5 and move in the direction of this vector, and in the opposite direction, then I obtain a certain line which is orthogonal, perpendicular to the green plane, because it's in the direction that is normal to the plane, and passes through the point 2, 4, 5. Just for fun, let me do this. All right.